So this is our second look at inverse operations. So this one, we're looking at only the common log. So the common log is when you have base 10, and that is what you are using on your calculator. So your calculator is only base 10. There's ways around that if we have a different base, but in this example and in our class, we don't have to use anything else but base 10. So I have my f function is the function, the exponential function, 10 raised to the x power. So the unknown is in the exponent. My g function is log of x. Okay, so again, just kind of a background between these two. An exponential function has an inverse of a log function. So as I said with the natural log, a log is just an exponent. So if I wrote the function 10 raised to the third power gives me 1,000, and I wanted you to write this as a log, it would be the log, common log, base 10, of 1,000 equals 3. So again, I'm using the exact same pieces of information. I'm just writing it in two different ways. This is the way you're used to seeing it as an exponent. 10 raised to the third power gives you 1,000. Now this is saying the log, which is base 10, of 1,000 is the exponent 3. So remember, a log is an exponent. So anytime you have a number over here that's by itself and you have log here, this number is the exponent on the base. And in this case, the base is base 10. Okay, so you're saying the exact same thing, just in a different format. So when you're looking at this, we're going to graph it so you can see that it's an inverse operation. Remember, inverse means they undo each other. The x's and the y's are flipped, so I'm going to show that to you. So in this case, if I put x is 0, 10 raised to the x power is 1. When x is 1, 10 raised to the first power is 10. When x is 2, 10 raised to the second power is 100. Now I'm going to go on the negative side. When x is negative 1. So remember, when you have a negative exponent, what that means is it has nothing to do with positive or negative. It only says flip it over. So it's 1 over 10 to the first power. So in this case, 1/10 is 0.1. 10 to the negative 2, so 10 to the negative 2 is 1 over 10 squared. So again, that negative says just flip it over, which is 1 over 100, which is, as a decimal, 0.01. Okay, so now I'm going to graph this. So I'll graph it in blue. Okay, so when x is 0, y is 1. When x is 1, y is 10. I'm going to do this. Ooh, let's see. I'm going to do this a little bit differently. I'm going to do it because I'm going to run out of room if I do it by ones. Okay, so I'm going to go, let's see. I'm going to do 10. Nope, I'm going to have to do more than that. 20, 40, 60, 80, 100, 120. Okay, so this is 100 here. Okay, so now I'm going to have to go the other way. So 10, 20, I can do it with ones here. Sorry about this. 1, 2, 3, negative 1, negative 2, negative 3. Okay, so now when x is 0, y is 1. So this is 10. No, 20, I'm sorry, 20. So it's going to be somewhere down here. When x is 1, y is 10, so about halfway. When x is 2, y is 100. When x is negative 1, y is 1/10, so it's very close. When x is negative 2, y is 100th. So again, you have this shape where it goes along the x-axis, it never touches the x-axis, and then it skyrockets after a certain time. Okay, so that is the exponential function. Now let's jump over to the log function. So with this one, when x is 0.001, if you were to plug this into your calculator, the log of 0.001 is negative 3. If x was 0.01, the log of 0.01 is negative 2. So remember how you have to kind of turn it around in your head. This is saying 10 raised to the negative third power gives me 0.001. 10 raised to the negative 2 gives me 0.01. 10 log of 0.1 is negative 1. So 10 raised to the negative 1 gives me 0.1. And if we had 1, log of 1 is 0. Log of 10 is 1, and log of 100 is 2. So the exponent on 10 that gives me 1 is 0. The exponent on 10 that gives me 1 is 10. The exponent on 10 squared that gives me 100. So now we can graph it. So when I have 0.0001, I end up with negative 3. So if this is negative 20, so it's going to be somewhere in here. And then negative 2, negative 1. When x is 1, y is 0. When x is all the way out here at 10, y is 1. Okay, so your graph is going to do something like this. Okay, so again, it's just a mirror image across the y equals x line. These numbers are switched. So in my exponential function, I have 0, 1. In my log function, I have 1, 0. Exponential function, 1, 10. In log, I have 10, 1, and so on. Okay, so it just switches your x's and your y's. That's the bottom line. So what this shows is these are inverse operations. Okay. So now what we're going to do is we're going to do what we did with the natural log and natural number, and we're going to go through and figure out how to solve. So because we are using base 10 is a what's called a common log. So that's the log button on your calculator. So if you had the question, like number 4 on page 106, log of 8.31, all you're going to do is you're going to plug in log 8.31, and it's going to be about 0.9196. And remember, the instructions say round to 3 decimal places. So you look at the third place, or you find the third place, you look at just to the right. The 6 makes the 9 go up 1, so it's going to be 0.92, because if this goes up to 10, that's got to jump up 1 more. So it's 0.92. Okay? Now, number 7 looks a little different, but it really isn't. The key is to make sure you finish the answer. In other words, in your calculator, you're going to go log 2, close the parenthesis, hit equals, and then divide by log 5. Okay, so log 2, if I were to work this out, and log 5, oops, I wrote it differently, log 2 is 0.30102, log 5 is 0.69897. So what you can do, instead of doing each individual one, you can do log of 2, close it, divided by log of 5, close it. And you get about 0.4306, rounding to 3 places. The 6 makes the 0 go up 1. So it's 0.431. Okay? So that make sure you know how to use your calculator. Okay, so now we are in section C where we are evaluating. So remember, logs undo base 10. So if you have the log of 10 raised to the 9th power, the log cancels the 10, so your exponent is 9. Okay. If you have 10 raised to the log of 2, the 10 cancels the log, so you end up with just 2. If we're moving on, so all of these are very similar to the ln key. Okay, so this is number 13 on page 106. So I have 400 equals 10 raised to the x power. So again, just like with the natural log and the natural number, if you start with an exponent, change it to a log to solve. If you start with a log, change it to an exponent to solve. So if this is in exponential form and it's base 10, I can rewrite this as log of 400 is going to equal my exponent. Okay, so base 10 of the total equals the exponent. So you can see I really am using the exact same information. I've just rearranged it. So now I just plug it into my calculator. Log of 400 is 2.60205 equals x. And it doesn't say what we're rounding to, so we'll round to 2 places. So the 2 makes the 0 stay the same, so it is about 2.6. Now, if you aren't sure, all you have to do is go check it. You have, right above your log key, you have 10 raised to the x. So you can do 10 raised to the 2.6 will give you 398.107. So it is close to 400. So again, these are not exact numbers, but it's close. Okay? All right. Next one. So if you're given a log, you're going to use exponents to solve. If you're given an exponent, you're going to use logs to solve. So number 14 says 50,000 equals 50 times 10 raised to the x power. You want to isolate your 10. I'm sorry, your 10. You're going to divide by 50, right? Because we want 10 raised to the x. We want to get that exponent, the variable by itself. So we're going to get rid of the 50 first. 5 goes into 5 one time, and 1 0 is left off. So we have 1,000 equals 10 raised to the x power. Now I can log both sides or rewrite it. Log of 1,000 is going to equal x. So log of 1,000 is 3. In other words, the exponent on 10 that gives me 1,000, 10 to the third power. Okay? And then the next one, now I'm going to give you a log, and you're going to use exponents to solve it. So it's log of 2x equals 0. So remember, this is base 10. This is the exponent. That's the total. Okay, so 10 raised to the 0 power gives me this. Well, 10 raised to the 0 power is 1. Divide both sides by 2, so I get x equals 1/2. Okay. Number 16. Number 16 says log of x minus 2 equals 1. Base 10, that's my exponent. That is my total. So again, all I've done is I've rearranged it. Log is base 10. That's my exponent, and that is the total. Okay, so now I just solve it. 10 to the first power is 10 equals x minus 2. I'm going to add 2 to both sides, so I get x equals 12, and that's my answer. Okay? All right, we're just going to do 2 more. And then I'll switch and go to applications. So 10 raised to the x plus 8 equals 20. So again, I can't do anything with that exponent and the variable until I isolate it. I have to get it by itself. So I'm going to subtract off the 8. So I get 10 raised to the x power equals 12. Now I can rearrange it. Log of 12 equals my exponent. So now I just go log of 12. Is 1.0791 rounding to 2 places, 1 point, the 9 makes the 7 go up 1. So it's 1.08. All right, and again, if you don't trust yourself, this, plug it back in here. 10 raised to the 1.8 should be close to 12. Okay, all right, last one. We have 7 equals negative log of x. All right, so just like we can't do anything until the base 10 is by itself, we can't do anything until our log is by itself. So I'm going to divide off my negative 1. So I get negative 7 equals log of x. Negative 7 is my exponent. Base is 10, so 10 raised to the negative 7th gives me x. So again, with a negative exponent, remember this is a very small number. When you have a negative exponent, you're dealing with a very small number. So what this means is I'm taking my exponent and I am moving it 7 times to the left. So it's 0.0000, that's 4, 5, 6, 7. Okay? So either way works. You can write it either way. Now, on your calculator, you might see it written like this. If you have a 1e, capital E to the negative 7, what it's doing is it's writing it as in scientific notation. That's what it's doing. So go back to that section on scientific notation if you need to be reminded on how to do that. All right, so we're going to switch now to application.